Hi everybody. In today's video, we're going to derive the quotient rule by using the limit definition of a derivative. So first, let's start off with the limit definition of a derivative whenever f of x is equal to g of x divided by b of x. So here is two functions of x, one's in the numerator and one's in the denominator. As we can see in our problem, it resembles this form, g of x divided by b of x. Now, when we put this in the limit definition of a derivative, f prime of x, or the derivative, is equal to when the limit of h is approaching 0, where on top in the numerator, we have to have our f of x plus h function. So this is where we have g of x plus h divided by b x plus h minus f of x, which is just g of x divided by b of x, all over h. Now here, we have two fractions trying to subtract from each other inside another fraction. So a way to simplify this is to make the whole numerator its own fraction, so we can combine the fraction in the numerator with the denominator. So here, if we just extract the numerator for right now, we have g of x plus h divided by b of x plus h minus g of x divided by b of x. The way to combine these fractions very easily is by using the cross multiplication method, where we'll multiply the diagonals together and then subtract them because we have a minus sign in the middle. So it's going to be b of x multiplied by g of x plus h minus b of x plus h multiplied by g of x. And then we also multiply the denominators together to combine this fraction, or to get b of x times b of x plus h. So those are the two fractions combined, and now we're going to plug it back into our numerator. So I just moved this over here, and now we're going to apply this into our limit of h is going to 0. The whole fraction was technically in the numerator. It's the same thing as now putting it in this form, where now the h is now applied into our denominator of that numerator fraction. So this is the same form as this fraction above. To actually solve the quotient rule, we're going to do a little bit of a mathematical trick in order to actually solve for it, where we can add 0 to anything, or we can multiply 1 to anything. It's the same essential thing, where the function doesn't go away. So if we add something to the numerator, we'll have to subtract something from the numerator as well. So let's say we add b of x times g of x minus b of x g of x. This changes nothing because this is the same thing as essentially adding 0. Now, what we can do is separate this limit into two separate fractions. So if we take the limit of h going to 0, let's separate it into one fraction and then separate it into another fraction. This first fraction, we're going to take these two indicated green dot functions. We're going to take our b of x times g of x plus h minus b of x g of x divided by the denominator. And then, now if we subtract it, or if we can add it in this specific case, what we'll do is take the remaining two numerator pieces and add them together. We'd have b of x times g of x minus b of x plus h times g of x, with the same denominator as before. H of b of x, b of x plus h. We can start to see a little bit of how this will resemble any sort of limit definition of derivative. But first, let's factor out a few things in the numerator and also rearrange a little bit. So here, we're going to have our limit of h approaching 0. We'll factor out b of x from our numerator, so it's just the same thing as saying b of x multiplied by the fraction of g of x plus h minus g of x divided by h. And we'll also put the b functions on the outside here. B of x times b of x plus h. We're not going to cancel out our b of x's in this case out in front because it will help combine the second fraction. So now we have our plus sign. We're going to factor out our g of x's in this case. G of x divided by b of x times b of x plus h multiplied by the fraction divided by h, b of x minus b of x plus h. Now, the second fraction is technically reversed, or it's in the wrong order. In order to get it into the right order, the same thing as adding this fraction here. It's the same thing as subtracting the reverse of this subtraction. So b of x plus h minus b of x, which is now in its proper form. We have two things that will converge to a limit definition. We'll have two things that converge to a definition of a derivative. So this will go to g prime of x, and this will go to b prime of x. And then the b of x plus h will just converge to b of x for our denominator. So when we actually write this out, after the limit has been applied, we'll have b of x multiplied by g prime of x minus g of x multiplied by b prime of x divided by b of x squared. So we combine the fractions here in the end to get the final definition. So this is actually the limit definition of the derivative, where f prime of x, whenever we have the ratio of two different functions of x, is just going to be our lower function multiply the derivative of our numerator function minus the derivative of our denominator function times g of x divided by our denominator function squared. So that's how you actually derive the quotient rule using the limit definition of a derivative. I hope you have learned something here today. Please comment any questions you may have about this, and have a great day.